All right, this is part 3, looking at least squares regression, and we're just on this last question right here. We need to finish up dealing with height and head circumference of children from a certain practice. So I'm working on part C. We want to use the linear regression equation that we have right here, and we want to use it to predict the head circumference of a child who is 25 inches tall. So on part C, you could say y hat equals 0.1827 times 25 plus 12.4932. 25 is definitely within the scope of our model because we have many data points right in that region. Okay, and so when I do this out, I get 17.06 inches. Okay, and then we want to know, is this head circumference above or below the average here? So when we look at this, so this is the 17.06 is our predicted value. And then when we look at the child with exactly 25, okay, that child, so the child observed at 25 had 16.9 inches for head circumference. And so when we look at this, we're going to look at the residual. And again, the residual is the observed minus the expected. Let's see, that's actually, yeah. So we take the observed minus the expected, and that is a negative 0.16. So when the residual is negative, this tells us that our observation is below average, below what we expected. Okay. I do want to show you in StatCrunch how we can find this prediction. So again, to get this data that we had, we go stat, regression, simple linear, and then our height was x, head circumference was y, and I could come down and it says prediction of y, and x value is 25. So then I'll compute with that, and I'm going to come down, and here's my predicted value. So when x is 25, my prediction is 17.06. All this other information is a little bit beyond the scope of where we're at right now, but that's how you can get it. Then in StatCrunch also, if you click this arrow, you'll see here's all of our data in a scatter plot and then our least squares regression line. So that'll take care of doing that. You don't have to graph those by hand. Okay, and that is actually going to be part, let's see. So we just did parts C and D actually. And then E was the least square regression line. So that's this guy right here. Okay, so we can see that. And next we have, so we'll just put graph in StatCrunch. Okay, F, part F says, notice that two children are 26.75 inches tall. One has a head circumference of 17.3, the other has a head circumference of 17.5. How can this be? Well, that's just, humans. So head circumferences vary from human to human. Humans have so many variables. So we'll just say, that head circumference varies. So even though they're the same height does not necessarily imply that they're going to have the exact same head circumference. Hopefully that one just logically makes sense. Okay, part G says, would it be reasonable to use the least square regression line to predict the head circumference of a child who was 32 inches tall? Well, if I look at all of my head circumferences, they're all pretty tight-knit. Like 24.5 is a low here. 25.75 is pretty high. So our range is very small, about 3 1/4 inches. 32 is well outside of the scope. And so would it be reasonable to make a prediction with 32? I would say no. 32 inches is outside of the scope of the model. Oops. So you have to take a close look at your data set before you actually utilize a data point, because I could put in 32 and I could get an output, but it falls outside of our scope, so its reliability drops drastically. So that's a look at least square regression, and if you've got any questions, don't hesitate to reach out.